Okay. All right. So today we'll cover second part of security principles, and note that these security principles are, very generic in nature, and most of the security system that we are going to design and develop, one of these principles will apply. Okay. So I have taken the contents from the same textbook which is available online at University of Berkeley website. Okay. And then of course during the course you will use different references, different books and so on, depending on what topics we are covering. So these are the common or what do you say, that known security principles, and some of these we have covered in the last class, like first few, I think up to this point we have covered. Yeah, up to this point we have covered. So basically what we discuss is that that threat or cyber threat or any threat in life, even your threat, for example, your to yourself, as a human being, right? It's an emotional threat, right? And so on. You cannot plan its defense when it happens. So you have to have you will have to plan right in the beginning the threat model, and then you have to based on that threat model you can have mitigation methods. Okay. Then we have discussed about trusted computing base. Essentially it means that, I mean, in any system, a small part of the system has to be extremely trustworthy. Okay, I'm not using the word here reliable, but in general it's a trustworthy. It means nobody can penetrate that, right? So for example, in a system there are about, even in a head there are about say 15-20 million lines of code. Not everything can be made extremely trustworthy, because it may have hundreds of applications you might have downloaded from various sources. However, a small part of it has to be trusted computing base, usually kernel or a small part of the kernel is which is considered to be unbreakable, absolutely trustworthy, right? Then we discuss about weakest link. Whatever you do, whatever kind of locks you put on your house in front, maybe $200 kind of lock in your home, but if you leave your windows open without grill, that is the weakest link. Similarly, in a system you'll have to, if you want to make whole system secure, then you have to have you don't leave holes, security holes, right? All parts which are part of the complete, what do you call that, task or something, okay, has to be secure. And then generally cyber criminals try to find out holes. Now many holes are okay, please mute yourself. Many holes are known, and companies work to solve that. So criminals try to exploit those holes, right? And then we have the point that we consider that human beings are in general the weakest point in security, and we'll also look at some examples how one can fool human beings in general to get into their system, okay, and cheat them or fool them. So one example we'll very often come across is that password sharing among spouses. When you have a girlfriend or boyfriend, or maybe you're married, and you share passwords, and it is seen that the couples in many couples at certain point in time in life, if there is a separation, then this becomes a major issue. Okay, so that is also considered as one of the major security threat, that don't share the password, even the people are your closest. Okay, because human beings in general cannot be trusted fully. Then we discuss this point is security is economics. Nothing comes free. Even if the lock you have put in, it costs you money. And you'll have to see that how much money you need to put into security. Okay, more money you put into security, then you'll have to, you can do only when something that you're protecting has to be more expensive, or its cost should be significantly higher. Okay, and very often you cannot prevent attacks. Okay, but you should know about it. You know, your enemy country, if keeps coming to your territory, and it happened with India. Okay, and if you discover it after 3 months, then protecting yourself becomes very expensive and very difficult. Okay, so you have to detect it immediately. You may not have a great protection system in the system, any system, but when somebody is entering or attacking, should be able to know. So detect if you cannot prevent, and then of course you can take actions. For example, if your machine is as soon as you come to know that somebody is attacking your machine, or there is a strange behavior in the system, you switch it off. Okay, and do something about it. Okay, so these points we have discussed. Today we are looking at the following point: defense in depth, least privilege, separation of responsibility, ensure complete mediation, don't rely on security through obscurity, fail-safe designs, and designing security system right from start. So these are again very general in nature, and you can apply when you design a system, okay, which is secure system. Okay, before that we'll spend few minutes about few things. This was a cartoon published in New York Times in 1993. And 93 was time when universities started getting internet, and then it was available to few people across the globe. In 94, first time I actually started using internet, and it's very simple. Okay, there were not websites available at that time and so on. You just use it for few websites were available, and it was simple. At that time, nobody knew anybody, right? On the other hand, you just need to have IP address, and then you can send whatever, you can send the data from one end to another end. So that's it. And most applications are very simple, like file transfer and so on and so forth. And then of course web pages just started coming in at that time. So you could be anybody. Here, for example, dog, and the other end nobody knew that you are dog. Okay, and then came time 2015, maybe 25 years later, that so it says that this dog says to puppy that, remember when on the internet nobody knew who you were. Okay, it means that 20 years back, 25 years back, even more, but I use internet, nobody knew who is at the other end. But now the time has come where on internet everyone knows you, everybody knows you that you're dog. Okay, though we say internet is a pipe, whatever you put at one end comes out the other end, but the other end, if the other end is interested knowing about you, it will know that from where the information is coming. Okay, and this information gathering was not the concept which has started happening now. So you go to, for example, google.com, amazon.com, or Facebook, Twitter, wherever, they know everything about you. They collect information about you. Okay, collectively, these 5, 6 companies or 10 companies know everything about you. Like even they know that what we are doing right now. Okay, so everyone now, internet wants to know who you are. Okay, does it mean that and cyber criminals will also know? Why not? Okay, so now the smart thing that you have to keep in mind is that when you go out and cyber criminals are watching you, then how to protect yourself. Okay, so best thing is that no, you become invisible. Okay, you become invisible so nobody can watch you. How is it possible? So is it dangerous that cyber criminals know you? Of course it is dangerous. Now they may not attack you right now because they may not think that as a student you may have money, but they may attack me because I may have money. Okay, so now the question I'm asking you is very simple, and then you start thinking about it. See, techniques you can find out, but you just Google it, you find out everything is available on net. These techniques. The important thing is that you should start thinking about it, right? So when you use internet, do you leave your digital footprints? Do you? Anyone? Yes.
Almost always.
Yes, almost always, right? Is it dangerous? Yes, it is dangerous. Somebody can look at your footprints and come to your doorstep, your door of your house. That is to your system. Okay. Now the question I'm asking is that do cyber criminals leave their digital footprints? Do they?
Prefer not to, cause
Yeah,
they will be tracked.
I mean, the smartest digital criminals, and usually these guys are very, very smart. They don't leave. Just don't leave any digital. Otherwise, they will get caught. Okay. Now the question that you need to ask yourself and need to find out after googling it, and also read. Those who have not done OS course or course on networking, just try to get some knowledge about it, and then start thinking about the following things. First thing is that do the website you visited know about you? Almost every website will, that is commercial in nature or non-commercial in nature. Even the honeypots will know everything about you. Okay. uh, does all of you are using ISP, internet service provider? Otherwise you won't get internet, right? Okay. So how do you connect to your internet, right? Most of us use Wi-Fi. From my desktop or laptop, I'm using Wi-Fi, and from Wi-Fi it is connected to ISP. Okay, and then from ISP my data is going. So now when you say that your identity or a machine's identity, what does ISP know about you? See, ISP is one that is giving you IP address. Okay, because when you boot up your machine, your laptop, you don't have internet address until unless you are given permanent IP address, right? Which doesn't happen very often. So now my machine does not have permanent IP address. I boot my machine. Okay, and I use DHCP that gives me IP address. And how my DHCP that's running on my Wi-Fi router get these IP addresses? It gets IP addresses from ISP. Each ISP is given a set of IP addresses, right? So ISP in Bangalore, for example, I'm using right now Geo net, is given set of IP addresses. When I switch to Airtel Wi-Fi, then my IP address that I will use will be different. So, but point is that ISP knows about my IP address and during what time I am having that IP address. Now, if I am doing, if I don't want to leave my digital footprints, such that somebody who has taken over ISP or wants to come through ISP will not know about me. So think about it. How can you hide your IP address? Okay. Second thing is what constitutes your machine's identity? What is the second thing? Anyone?
MAC address.
Yes, MAC address is basically your Ethernet card address. Basically all interface address, I would think. The machine may have multiple Ethernet layer 2 cards, right? Okay. Unfortunately, we are using only one type of layer 2 technology, which is Ethernet. Okay. And okay, so do you think the ISP will know about your Ethernet address, MAC address?
No, sir.
Oh, that's ideally it should not.
Sir, it knows our router IP address. Oh, MAC address only, na?
Okay, so now this is where the confusion is. They will always know they collect this data. How do they collect it?
From the packet headers, I guess.
So basically, IP address of Ethernet address of router, your Wi-Fi router will go to them. That information anyway is there because your packet travels only on layer 2. Okay. Also they collect information about your laptop's Ethernet address. How do they collect it? That you have to figure it out. Okay. So it means that now your Ethernet address and your IP address is out. Okay. Now you'll have to find out how to protect yourself and your IP address. Yeah, at most you can do, you can change your IP address from IPv4 to IPv6 if you have multiple service providers connection, but you don't have choice about choosing your IP address. Okay, if you want to receive the information back, you can you can write some software and then change IP address, it will go out, certainly. But receiving, if you understand IP routing, IP addresses are not flat addresses. These are hierarchical addresses, right? So the IP address that I get in Bangalore will have some information, hidden information about my location so that routing can happen. Okay. So knowing your IP address, which is legal IP address, anybody can know where you are. Okay. So this is preamble. Just start thinking about it and reading about it. So now let's come to topics of today, which is defense in depth. Okay, have you ever visited Rajasthan and then went to forts? There's a difference between fort and palaces, right? What is the difference between fort and a palace? Kila, we say in Hindi, right? Kila. राजस्थान में एक किले पे गए, which is on a hill, and then around it is a wall, and there is a water body. ठीक है ना? So why do we do that? Why they used to do in make forts in this way, such that if enemy attacks, then enemy has to cross many of these hurdles. So that's called defense in depth. So multiple layer of defenses can be layered together, and attacker have to breach all these defenses. First outer wall, then there can be water body, then there can be a depression, and so on. Okay, all right. So now how many of these? I mean, can there be a fort with 50 of these hurdles? 10 walls and then water body, then a depression or ditch, and then no, there is, it all requires money. So every system has got to have limited number of these defenses, right? So only, say for example, 2 walls are better than 1 wall, but 101 walls are not much better than 100 walls. Okay, so there is economics here, right? And that is to be considered. So this is an example. So this is similar to what we mentioned, that in Rajasthan Kila, any fort you go, you find this kind of structures, right? There is a protection here, then there is a, somebody has to cross this area, and then there may be some people watching from top, and so on and so forth, right? And there can be depression and so on. Okay, all right. And so in a system also, we need to create multiple layers of defenses. Like for example, this may not be true for all systems. For example, if there's somebody trying to attack, it has to go, first thing is that external firewall, then it somehow it crosses it, then there's a protection from OS, then there is a some kind of antivirus system which can detect, and then of course, and software keeps updating, so security patches are there, right? It means that somebody can get into here is because of some hole in the software, some security, lack of security, right? Okay, and patching, if patching is done frequently, then these holes are covered. Okay, these holes may be there in all this, but hole may not be there in say for example OS and other stuff. And then you have at the end, if you have user access control, right? Okay, so we can create multiple techniques, we can use multiple techniques one after other to create robust defense. So any system will have multiple layer of defenses. Okay, think about your laptop, what all defenses it has. Okay, then second another principle is least privilege. Okay, so this is like minimum permission an entire program needs to be able to do job correctly. Not everybody should have the same privileges. Say for example, you work in a company, say Google for example. The most important thing for Google is all these companies, Amazon, Flipkart, Google, Twitter, most important asset for them is the complete system, the software, right? Software hardware combination. Okay, when you join a company like this and you are asked to develop some software, maybe a feature enhancement or something, then are you given access to the whole source code of complete system? No. Are you given even access to source code of something you want to test with? Possibly yes, but mostly no. Okay, you may get executable version. Okay, so you are given minimum things that is needed to do your job perfectly. That's it. Okay, for example, in a bank, you have bank has money and jewelry and all that, right? And then the lockers are there, and nowadays there may be a digital locker, and there must be password, user ID, password, and so. Let's assume. And do you think that everyone who works in the bank will have the same privilege to know the password? No. The security guard may not know about where even the digital locker is. All right. So something happened in my company, and then I learned that actually these principles are really applicable. And it so happened that okay, a person who was working in HR, human resource department, because we are kind of startup, just 150 200 people, so the admin guy was also quite new to the job. By default, everyone was given access to the source code. Okay, this HR person one day made a request for something, some code is not working in source code. Okay, and then system admin guy came to me and asked me that this person is asking for permissions, some more permission. Then I asked, what HR person has to do with the code? Okay, now by default, even complete source code of the product, complete product is available. And this HR guy's friend was working in competing organization and trying to get into our system, and actually got into and want to take away. Okay, then we realized that yes, I mean, why somebody who is in supporting department have any access to even source code? Their job is they should be given access only to some data related to HR. That's it, and that too what is necessary. So this principle applies everywhere. Wherever you work, you will be given permissions, or anybody, if you give permission, should be minimum for the person to do the job. Okay. Okay, how does Unix fare with respect to least privileges? Very poor. Very poor, right? If you run an editor, you as a user process, you means that your user process runs an editor, and whatever access rights you have, okay, your editor will also have the same, right? Like read, write, edit, delete, etc. And Windows are equally bad. Okay. All right. All right. So now related point is that we can of course set different processes with different access levels, right, or different rights. Okay. Okay. However, okay, look at this point that you already know. The different process and system are basically separate. Okay. So for example, when you design a browser, and browser gets content from website, and it can have malicious contents, right? Not all website you visit are pure, or they don't have malicious intent, right? Some websites may have malicious intents, especially honeypots, right? You go to, in case you have ever gone to some sites where your parents never want you to go, and then I'm sure that those websites will have all kinds of malware. Okay, so you download something, and now it comes to your browser, and you see that these contents that you're downloading is not static contents, all programs. Okay, and then that program that you have downloaded executes and finds out wholly on the browser, then it can manipulate everything. Yeah, all user files it can encrypt and so on and so forth, right? So now this trusted computing base is a complete thing, the whole browser. Okay, now we can limit this. Say when we know that programs that you're, or data you are getting from website can be malicious, then you run it only in a sandbox. Okay, a sandbox, or basically split the system and run this in a system which is which is sandbox, which does not let the bad things go out. Okay, so sandbox is an isolated environment to run unsafe code. So damage in the sandbox will not spread anywhere else, right? So you create sandboxes and make sure that because of this, it does not impact other parts of the system. And then here the sandbox is rendering engine, because 70% of vulnerabilities are in those rendering engines. Okay, all right, got this point? So least privileges are to be given when you are designing system. The user should get the least privileges. Okay, all right. Any question? Okay, now question I am asking is that do you think that CEO of the company should have access to the whole source code? Or head of sales, senior vice president of sales should have access to source code? Yes or no?
Yes, sir.
No. As simple as it. What CEO has to do with source code? Do you think the CEO will do coding or bug find or do code reviews or write test cases? Nothing. CEO might have come from MBA institute, some MBA from somewhere, has no clue of what happens inside. They may have idea about, but he should not. Even the owner of the company should not have. Okay. Why should? I mean, again, you know, it's a bad examples you learn in life. In the same company, source code was available to all, including sales guys. And now, as a result of that, after a few years, that guy has anyway left. And then in China, the source code is available and he's selling that source code. Okay, while, you know, maybe senior most person may think, CEO of the company thinks, then he is overall in charge, he should have right over everything. But this principle says that CEO should not have access to complete source code or IPR of the company, because tomorrow leaves and joins another company, starts similar company, has access to all this, right? That's the reason no company gives access rights even to the owner, because owner has created these policies, to anybody. Okay, all right. Just understand this. Huh? Okay. Separation of responsibility. Okay, given a task, okay, there must be multiple people who are required to do the task. Say, for example, when you go to airport and you show the ticket and your ID card, the security guard should not take you directly to the plane. Job of security person in front is just look at the card that you have, ID card, look at your ticket, validate few things, okay, and maybe some other things like, okay, some through intuition may have some doubts, and then will, in case, you know, they find me that something malicious, then we'll send it to for, you know, higher level of checking. Then you go inside and then go to the counter, then again look at your ticket and then validate it, and so on and so forth. They will find, they see, a security guard cannot find out whether a ticket is genuine. You can always create a fake ticket, right? But the person inside, or check-in person, check-in officer, you know, will check whether the ticket is legal ticket. Look at the name data in the database, and then what is the next step? You go to security, and then you're, you know, again you are looked at, your stuff is looked at, and so on. Then you pass on to the next level, you know, at the gate, and then they look at the ticket again and then let you go. Okay, so there is no single person does the job. So if even if one single person is doing something wrong or is a malware in a system, then it will get caught. Okay, so basically it means a split of privileges. No one person or program has complete power. All right, so it's more likely that single party to malicious than all other parties. So if one party can be malicious, but not all, so still threat will not go deep inside, right? You cannot, even if the security person in front is your relative and friend and you want to fake it, you're traveling with fake ticket, you will not be able to pass many levels, right? All right. Okay. Now, third is this point we have already discussed, that in a system, all the access requests, from user plane, you go to kernel plane through system calls. All these system calls have got to pass through one mediation box. Okay. So, for example, we discussed this point about reference monitor. There is a single point through which all access must offer. So, in general, in a system, there has to be a part which is very reliable, very trustworthy, and then all requests have to pass through that. Okay. All right. And this reference monitor, of course, should have correctness, completeness, and security. Okay, this is another view of the same thing. So this is a reference monitor, and this reference monitor works based on the policy. Okay, even if you're the CEO of the company and then you don't have ID card, you're trying to enter the office, you will not be allowed to. Okay, so here the reference monitor becomes the security. If there is just one security person in front, in the building, then that person becomes the reference monitor. Okay. The next point, which is also important, is that you cannot rely on security through obscurity. Very interesting point, right? Say, for example, and this very often used in encryption. So one way to hide or create privacy and confidentiality is to encrypt the data. So encryption is that, suppose you're sending a message in plain text, after encryption, it becomes a, something which cannot, if you try to read it, you cannot make out. It's some combinations of zeros and ones and done in a particular way. And then same decryption you can apply at other end to get the original message, right? Now you think that this decryption algorithm that you are designing should be secret? Should it be secret? I'm asking a question.
It should be
Okay. Yeah. So that's the point. So, but do you think that most encryption algorithms that are available in open source, which all companies use, including Google, the algorithm is known to everybody else, right? Okay, so this is a point that security cannot be through obscurity. Obscurity means that you create your encryption algorithm. Everyone creates. I will create, if I want my data to reach to other end, I will create my encryption algorithm. No, which my friend other end can decrypt. But all of us use encryption, known encryption algorithm, right? So we cannot do this because the thieves or cyber criminals will also know. They can easily find out and they can create that. Okay, then you are in trouble. Okay, now this is also known as Shannon's maxim, or and the same thing is in different words is called Kerckhoffs's principle. Okay, now it's something like this. The principle states that the attacker knows system that they are attacking. Okay. So security through obscurity refers to a system that rely on the secrecy of their design. Secrecy of, say, for example, encryption algorithm. How does it encrypt? So if that cannot be made secret, right? Okay, algorithm and source code to secure, right? So obscurity is because you are obscuring or not letting anybody know your design of, okay, because it's difficult to keep the design secret. Okay, so many systems in the beginning tried to do this, by secrecy of the code or design, and they failed miserably. So the question then you can ask yourself is, this open source applications less secure than closed source applications? Linux is open source. Is it less secure than Windows?
No, sir.
No, everywhere, most of the servers around the world are running on Linux, and then you can also get the source code for this encryption algorithm that's using. Okay, so okay, so the point is that open source applications are not less secure. You cannot say that. Okay. Second principle, or based on the same principle, is Kirchhoff's principle, that the one which we discussed, the cryptographic system should remain secure even when attacker knows all the internal details of the system, or that is algorithm. The only thing that creates the whole system secret is the secret key, and that's the only thing. If you should know secret key and use algorithm, and then everything becomes secret. Okay, so system, basically, if key is leaked, then you change the key. That's it. While instead of changing the whole system, which is impossible. All right. Okay. So understand this point, right? So there's a reason all these encryption algorithms are known to everyone. Next point is the fail-safe defaults. Okay, when a failure happens, then system should go to fail-safe state. So for example, when a firewall fails, then it will not allow anybody to enter, and everyone has to take explicit permission. Say in IT Goa gate, main gate, okay, there's some security guard, let you in. In general, they want to stop anybody, and let's assume something happened inside. Some incident has happened, some fire incident, or some theft, or something happened. Then they will not let you in. You need explicit permission to get inside. Okay, then they will start doing all security checks. All right. So fail-safe defaults are, choose default settings that are fail-safe. Okay. All right. So fail-safeness we can define as, unless a subject is given explicit access to an object, it should deny the access of that object. Okay. So explicit permissions are required, or access permissions are required. So this principle requires that default access to an object is none. So when there is some major incident happen, and you as or some senior professor or head of department, or even security in charge wants to get into, he or she will be questioned. Okay, has to get explicit permission. So there's a point. And the perfect example is firewall. So firewall works by default deny policy that starts with denying all accesses and allowing only those which have been explicitly permitted. So in order for this mechanism to work, so if security mechanism fail or crash, the system will default to secure behavior. It means that don't allow anybody to come inside. Okay, all right. Okay. All right. And the last point, last principle is that you cannot design security as an afterthought. Just don't do that. If you want to design a system, you have to have design concepts, principles in mind right from beginning when designing a system. Even you make a house, independent house in a plot, then you have to think right in the beginning and tell your security requirements to your designer. Even if you want to have a safe inside, a safe can be what? I mean, it can be in open, which everyone can see, or it can be hidden inside a floor. Okay. All right. So right from beginning, you have to think about security. All right. So you'll have to keep these security principles that we have discussed so far in mind and come out with right design or architecture before doing the development. Okay. So when you apply these concepts to system development or software development, you'll have to think about it. Okay. And why most of the systems are insecure? Because nobody bothered in the past 30-40 years to make systems secure while coding. Because languages you are using. For example, I mean, are you using C or using Python or you're using something else? That also has security implications. C is, for example, extremely powerful language. It allows you to do hundreds of things. Okay. But if you don't know how to use it, then you will leave a lot of security holes. Then the language itself for a very ordinary programmer becomes a tool, which is not properly used, right? It's kind of a ordinary programmer will leave a lot of security holes or security vulnerabilities, because if an improper use of pointer can be a security hole. Okay, so right from the beginning you'll decide what data structures to use, what are the APIs. Okay, how many whether your access requests are going through monitor or not, all these things you'll have to create. Okay, what happens if there is an attack? If you design a system that cannot withstand attacks, then if you design a website, okay, and that cannot take attacks, it will be down most of the time, because sometime or other, most of the time there are some attacks on the system. Okay, all right. So if you don't do that, and if you're making a house, be ready that your house will look like this. If it is an afterthought, then it will be unsafe and dirty, ugly looking. Okay. All right. So I would request you to go through these slides. Okay. It's called Big Bounty Program. Is there anybody who's participating in this? You can make money. Actually, you can make huge amount of money if you want to. Something in the order of few $1,000. Very easily you can make. Anyone here in the class? Do you know about it? Anyone?
Yes, sir.
Have you tried Big Bounty Program, participating in?
No, sir. Like,
Okay, all right, good. Okay, so Big Bounty Program is basically offered by companies. So for example, it could be Microsoft, Google, or most of the companies offer these programs. The reason is as follows: that programmers or developers work in a particular mindset, and also they develop. They are more concerned about developing things, creating something with feature in mindset, and then testing cannot be complete. Any system cannot be tested, software system, because the way software can behave, a fairly large software, is millions of ways, and you cannot create millions of or billions of test cases. It's very expensive process. So now holes are left out. In any system there are holes. Now you can find out those holes, and then companies pay you money for that, because it's a very cheap deal for them, right? They can get they come to know about security bugs at very low cost. Okay, so the company pays something like $3,000 and now 20K per bug. Google can pay, Facebook pays around 20K, Microsoft pays about 150K. K means 150,000 US dollar. Okay, and then you can also, which is not recommended, but cyber criminals also buy this bugs from a programmer or the person who's willing to sell. Okay, so you can know, and they publish it, right? So there are many advantages. First thing, you can get this source, you can actually use that application also, and then try to break it and then make money. I mean, if you can get even 10K, it's 7 lakhs, your education becomes free. And I'm sure if you try during summer, say 2 months, you can surely crack at least one. All right. Okay. So that's end for class today. So we have studied all these concepts. First thing is that we need to know our threat model. And then any system, we have to have a TCB, a part of system which is absolutely reliable. Then when we're designing system, we'll have to look at the weakest link. Okay, that can be broken by criminals. So we have to make sure that all pieces of the chain are strong and secure. Then of course, human factor, despite creating whatever strongest chain you want to create a system, human beings, because they have access to the system, can be possibly weakest link. So don't be weakest link because all of us can be weakest link for any corporate or for our own wealth. Okay. Security is economics. You'll have to do cost benefit analysis and see how much to secure. You cannot put in $1,000 lock in your hostel room. It's meaningless. And then you need to know somebody is trying to harm you, that's harm your system, and just detect it if you cannot prevent. Okay. Say for example, even at personal level, somebody is trying to harm you, then you need to know that, then you can change your ways, right? You can move in different direction or something like that, even if you don't have security guards. Okay. All right. Then defense in depth, single mechanism prevention may be good if the prevention mechanism is extremely good, but in general there are multiple levels of protections that's desired, and not everyone that's developing a system or using a system should have all the privileges. Then not a single person have complete responsibility for the task, so split the task into multiple pieces, and each piece of the code or each person should do different tasks. Okay. Ensure complete mediation, it means that most TCB, all the access requests have got to pass through TCB. And then we cannot design a system, secure system, which is obscure in nature. So let security algorithm be known to everybody, and then the key should be something that's private. And then if system fails, then it should come to fail-safe state, right? Deny all permission. That if something happens to the system, then system should get into fail-safe state. And then security cannot be afterthought. It has to be, any system that you plan to design has to be designed with security in mind, such that security is embedded or incorporated in the architecture of system right from the beginning. Even the requirements gathering, when you do it, there must be something for security. All right, that's all. Any question? Okay. All right. Thank you then. Bye.